talk about the 8.44, the law of large numbers. The key concept here for the law of large numbers is as the number of trials increases, the experimental probability approaches the theoretical probability. Think back to about our rolling the dice. The normal distribution. The graph of a normal distribution is continuous, okay, bell-shaped. So that means it can pick any number, a range of numbers, bell-shaped. You know, I keep asking that question, ooh, do you believe in ghosts? That's my ghost. And it's symmetric with respect to the mean. Okay, so the mean is a measure of center, it's right there. Symmetric, it just basically means this is half and this is the other half on the other side. So I like their horns, I don't know. The mean, median, mode are equal and located at the, these are what? Measures of center. They're pretty much the same. So when you're using the calculator and you're getting just the mean, median, mode, and all those numbers are pretty much the same, then it's normally distributed. The curve approaches but never touches the x-axis. So they're talking about like right there, they shouldn't touch. And the total area under the curve is equal to, what was the number we had before? 1 or 100%. Think of weather, right? If it's going to rain 5%, that means that it's sunny 95%, or won't rain the other way. All right, let's try this problem here about soccer. All right, we have the total number of goals scored by each player of a soccer team during the season. Create a histogram, so that means they're touching. And then determine whether the data can be approximated with a normal distribution. Okay, let's put the title, goals scored per player. Okay, and let's pick the smallest number and the biggest number. So I have 0 to 11, looks like. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And down here is the number of goals. And this is our frequency. Remember, frequency just means our count. Okay. So let's just count. And again, this little technique of just check marks are super helpful. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So it looks like zeros are the most. Let's go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So 14's up here. Okay, let's do... Why do I do that? Put blue check marks. Are you following what I just did? Blue check marks, and I drew a black box. Okay, let's try... Now I got this. Goodness gracious. Okay, there we go. Alright, let's try green now. Let's do the ones. 1, 2, 3, 4, 5, 6, 7 ones. And 1, 2, 3, 4, 5, 6, 7. So that'll be right here. Okay, and the twos. 1, 2, 3, 4, 5 2s. Oops. A little bit wider there. Equal width. Let's try a different color here. Let's try purple. And what do we got next? 3s. 1, 2. And I just didn't write down all the numbers there. Do you see that? Okay, any 4s? No. 5. Let's see, 1 right there. Any 6s? No. 7s? No's. 8? How many 8s? Same thing. 1. How many 9s? 1. It's supposed to be red. 10, and then you have an 11. Okay, now this is the fun part. You get to kind of put you kind of go over the peaks here. Okay, does that look like something where all the data is in the middle? So we say this data set is skewed. And to remember, the skewness is where the tail is, and the tail is where? This is here on the right, skewed right. Means there's no data to the right. Thus, the data cannot be approximated with the normal distribution. Okay? All right, go ahead and do the same thing on the next problem here, and then go ahead and press play when you are ready to see the solutions. All right, question number 6 about the track times. Now this one's a little bit tricky because they're all in the 14s. So if I were doing this, you can do something like, maybe over here you have 14.0 to anything that's about 14.1, 14.2, 14.3, 14.4, 14.5, anything up to 14.6, 14.7, 14.8, 14.9, and that'll be like 15. And you can just do like a little, so time measured in seconds. And what else we got up here? 110 meter hurdle race. And this would just be our frequency. Okay, so 14.75 I'm going to put in this bin right here. And I'm just going to do a tally down there. 14.77, 14.31, 14.83. It's between 14.8 and 14.9. 14.84, 14.35, 14.69, right there. 14.63, 14.74, 14.2, 14.25, and 14.93. Okay, so I do not want to put up here 10. That would be a bad number because my numbers would be kind of squished and doesn't really show the data. Does that make sense? So maybe you do it by, I don't know, one, I got to be equally spaced, 2, 3, 4, 5. Not a great job over here. Okay, so we have 0, and then we have 1 in there, and then we have 2, 0, 0, 0, and then 2, 2 in here, and then 3 in here, and then 3 in there, and then 1 in there. And then just come back here and try to draw over what's happening. Okay, now pay attention. You're going over the peaks, but you actually have to go down here because there's no data, right? This one is, I would call it bimodal. There's kind of like 2 peaks here. And that's not unimodal and symmetric, okay? So I would say, just use the same sentence as the last problem. Data set is not, that's an N, normally distributed. Okay?
24 hours in a day, and I get to do math, hey hooray. Y equals mx plus b with Mr. Ng, we're making history. Pythagoras, Euclid, and Gauss, learn the math and you'll become the boss.